We'll proceed in vector and commercial calculus. Vector and commercial calculus. Okay, vector and energy calculus. So, very nice vector you are. Because of you only, we are proceeding in vector in an energy calculation. Energy through algebra is possible, but direction is not possible. We need direction. Without direction, then we cannot compute path independence and this kind of that is very intricate in the energy computation. So, Mr. Vector, so thankful to you that you provided a way to anything. If it is a numerical science, if it is a numerical science and you add in numerical science, if you add vector, it becomes direction oriented numerical science. If there is an algebra and you add vector to it, it becomes direction oriented algebra. So, what about direction oriented calculus? What about energy calculus? What about commercial calculus? Anyway, now when we talk about energy, then certainly energy, when energy is there, the energy source is there. When energy is there, energy source is there. I have given example like if there is a consider that there is a satellite that is making round of the earth and satellite is throwing signal. Okay, my mobile is a satellite mobile and now it is in the signal of the satellite. Now when I switch it on, it connects to the satellite and then when I talk to anyone, then signal is going to the satellite and coming back to that person. Okay, if no one is talking, then still satellite is throwing electromagnetic radiation on the earth. Still, that's how when I switch on mobile, then immediately it catches it. But if 100 people are connecting to satellite, then energy computation in the satellite will be more because people are connecting to it. Okay, similarly, if there is a magnetic or electromagnetic energy source, if magnetic or electromagnetic energy source is kept, then all around it there will be a magnetic force vector that can be seen. Okay, the example what we are giving, consider there is a magnet is kept here. Because of that, magnetic force is like this. If I take an iron here, then suddenly it will start moving toward the magnet. Okay, if iron is not there, still magnet has magnetic field all around. Okay, toward the toward the radius of the, what is the direction? That is the radial. If this is the magnet and I make a circle, then circle radius that is going toward the magnet center, that is direction of the force. If any iron comes into the picture, suddenly it will start moving toward the center of the magnet. If it happens, then people would say, see, so nice, so nice, so nice. If you keep doing it, if you keep moving hundreds of iron toward the magnet, then magnet would start demagnetized. And after some time, it won't be magnet at all. Because magnet has energy and when iron is moving towards magnet is working, it is losing energy because it is moving, nothing is free, energy is changing its form, magnetic field to kinetic energy. This is what is happening. And if so many irons are coming, anyone can try, keep a magnet and so many iron particle, you can just it will attract all the iron particle towards itself. Okay, now dissociate and try again or put a tons of iron particle, it will try to capture everyone, then slowly it will start demagnetizing because whatever energy it had, that energy is being consumed in moving the iron particle. So energy is change its form. Now after some time, there won't be any energy in the magnet at all. Okay, that is the fashion that can be called as conservation of the energy. So, vector calculus, we are in phase of calculating energy. Now, we have energy source as magnet. Okay, like that, I have 100 energy source. 100 energy source. One energy source is earth also. If there are 100 energy source, how I can differentiate among them? Someone would say, then look for them the force field. How powerful the force field? Through that you can kind of discriminate among the energy sources. What are the other factors through which I can discriminate among the energy sources? Okay, then other factor through which I can discriminate energy sources, there is a new term comes into the picture called path independence. This is what in the past video we were talking about. Path independence in energy source. If energy source is path independent, then if I move a iron part, if I keep an iron particle and it attracts the iron particle, if iron particle moves from one position to another position, how much energy this magnet is losing? It is losing some energy, right? Because energy is converted into kinetic energy, moving. If that is the case, if I now I take a this is what example I keep on giving. Now consider that there is a iron is a bolt, nut and bolt. Hope there was a nut, right? Still it is with me. I try to show it. There is a nut. Okay, so simple small nut is there. This is nut. Nut will go inside bolt, and then we can put nut inside the bolt. If nut is going inside the bolt, now bolt I can put it inside now. Now bolt, if I keep the magnetic field again, bolt will try to go toward the magnet, and has to travel like this only because this is the path given to him. And bolt will come here and it will stand here because beyond that it cannot go. How much energy that magnet has lost? This is called path independence. If magnet has lost same energy, if the bolt was moving in a straight line from same begin point to end point, and it is losing same energy when it is moving in a circular fashion or a straight line, but begin point and end point is same, then the energy source is called path independent. Energy, the way energy source is losing the energy, it is dependent upon the begin point and end point only, not on the path it is taking. Through this, I can differentiate two energy source. One is path independent and other is path dependent. Amazing, mind blowing. Now, if it is path independent, doesn't matter what path the particle is taking when it is going toward energy source. Only thing is begin point and end point is concerned. Then all type of energy source comes into the category of path independent energy source, or the force field through which it is attracting the particle. That force field is called path independent force field, force vector field. But if it is path dependent, it matters that if iron bolt is moving from one location to other location, which path it is taking? If it is taking a straight line shortcut, then energy that is going away from the energy source is less. But if it is taking a circular path, then energy source is losing is more. Then it dependent upon the path dependent. If there are many sources, energy sources are path dependent, then what is the measure that I can calculate which is what? How much it is path dependent? How much? If it is severely path dependent, then if someone goes in a straight line and someone goes in a circle and someone takes even bigger path, then severely energy will be changed drastically. The energy computation will change drastically. If it is very less path dependent, more or less it is path independent only, less path dependent, then it won't change that much. If this length is x meter and this length is 2 pi 2 pi x by 2, and this length is x square, it will not matter much. Little bit it will be more. But if it is severely path dependent, then it will matter a lot. With that, I can know that which energy source is of what quality. This is what people say. Not only the force field, the path dependency, the kind of stage, at what stage the path dependency is. With that stage, people try to understand what quality of energy source is, how to calculate what is the standard, what is the quality of the path dependence. Then people calculated it is nothing but okay. Then what this is the question. Okay, what anyone would do to compute the extent of path independence? What anyone would do to calculate the extent of path independence? Sorry, path dependence. What is the extent of path dependence? Okay, the extent of path dependence. Now people started thinking how we can calculate extent of path dependence. If it is path independent, then begin point and end point only matters as far as energy calculation is concerned. If there is an energy source, an item is moving from point A to point B, then force field multiplied by the point A and point B is the energy computation, not the path. It is taking a straight path or curve. Like many times we have given example. If someone drops a ball from one location and to the earth, then how much energy earth is losing? Earth is losing energy, right? Because item move from one point to another point. Someone losing energy. Someone is working for you. Or someone, the person, he dropped the ball on a staircase. The dub 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 like that. He went to the ground floor. How much energy earth lost? Same energy. Doesn't matter which path it is taking. Begin point and end point only matters in the energy computation if the energy source is path independent. Earth is energy source. This is the what is lacking in the Newton's fundamental. I'm not saying Newton is a very small scientist, very powerful scientist, much powerful than I can imagine. But still, energy computation is lacking in Newton's theory. Everywhere force, mass, acceleration, momentum, power, and this kind of thing. Energy is missing, and that was finally fulfilled by Einstein, that energy computation. So if you go by the energy, energy cannot be created, energy cannot be destroyed. I am not very supporter of energy cannot be created. If that is the case, then this full universe would not have been created by the God. I mean, God created, this is my word, God created technology and technology created the universe. So certainly there would be technology to create the energy. But anyway, nowadays the fundamental is energy cannot be created, cannot be destroyed. Okay, energy changes its form, one form to another form. But at the end, energy is constant. Form are different, but energy is constant. If I call it a potential energy, then it is changing into kinetic energy. But energy is same. Okay, potential energy is mgh, then kinetic energy is mv square. That much, that it is changing the shape. Magnetic field has some energy, and if iron is moving toward the magnetic field magnet, then the magnetic field energy is getting converted into kinetic energy. So, but at the end, energy is same. Energy cannot be destroyed, it changes its form. Okay, in that way, now we are kind of calculation of the what is the power of the path dependence factor in the energy source, path dependence. So if it is path independent, then only begin point and end point matters. Consider that begin point and end point are same point. From this point, the kind of consider that a particle, okay, I just left one iron ball here, okay, and then iron ball is, consider iron ball has internal energy also. It has fuel. There is a, consider there is a small motor made up of iron, but motor has an engine also, and motor is rotating from here, going here and coming back here. Motor is rotating from here, going here and then coming back here. Okay, or if it is path independent, or someone can think like, if there is a magnetic field here, if I leave one iron iron bolt here, bolt would rapidly move in the magnetic direction, and when it finds a circle kind of thing and it cannot go, then it will complete the curve. If consider this is completely frictionless, no friction at all, zero air, we are trying it into a vacuum where there is no air, no media is there. If a bolt is moving toward the magnet with a high force, then here it will make a rotation and then it will come back to the same location. If it comes back to the same location, then energy dissipated by the magnetic field is considered as zero. Zero means it did not lose any energy. Moving item from here to here, it lost the energy, but it regained, but it went back to that location. If it reaches that location, then it is a matter of path independence. But whatever it. Anyway, leave this fundamental. Now consider that an item is moving in a force field, and it is moving from here and coming back to here. If that is the case and it is path dependent, if it is path dependent, then the energy computation from the energy source is dependent upon the path, not on the begin point and end point. If that is the case, then if begin point and end point they are same, still energy computation is there. If it is path independent and begin point and end point is same, then there is no energy computation. Since it depends upon the begin point and begin point and end point are same, then energy computation is zero. Because no energy computation can happen. Because begin and end are same. If I go with integral calculus, what is the energy computation if item is moving from same point to same point? It did not move at all if it is coming back to same. If it is path dependent, then energy computation is there, and energy computation is different for different kind of path. If path is elliptical, then energy computation is different. If path is circular, then energy computation is different. If path is circular but circle is small, then energy computation is different. If path is like a staircase, then energy computation is different if it is path dependent. Okay, whatever it is. Now we are trying to find the nature of the energy source through the path dependent fundamental. What is the nature of the energy source? Anyone would say that nature of energy source, if you're talking, then for different kind of path, nature of energy source will be different in the energy that is consumed by the energy from the energy source. Moving an item from one place and back to another place with different kind of path will be different. Okay, then what is the constant thing I can get? Try to calculate energy, that is energy computation from for a point for any particle in the force field of the energy source from same point coming back to same point, one point coming back to same point. What is the energy that is consumed from the energy source? Divide it by the area. Divide it by the area, then it is something that energy consumed from the energy source, a work done by moving one particle from one point back to a same point in a closed loop, divided by area of the closed loop in a one force field, vector field. Vector field means of algebraic vector. Algebraic vector is a vector which has its xy component as algebra, not in constant form. 2I plus j is not an algebraic vector. It is a numerical vector. xyi plus x plus yj. This is vector field, algebraic vector, where 2I component and j component are algebra, because it will keep changing here and there where if you change x and y. So if I have a force field and if I calculate the energy computation in a closed loop from a point and coming back to same point, what is energy consumed divided by the area of the closed loop, that now it talks about some kind of generic way. Now it is area independent. If I calculate the energy computation and then energy computation for a closed loop and then divide by the area, if closed loop is bigger, then energy will be more. Then you divide by the bigger area also. If closed loop is very small, the energy computation from a point coming back to the same point will be less because displacement is less. Then area is also less. So whatever the energy consumed divided by area or energy consumed per square meter of the area, per one unit of the area. If I go with that, then again we are coming as path independent. Path independence in the sense it does not matter which path it takes. It takes a big circle path, then big area division. If we take a small circle path, then a small area division. If we take a staircase path, then in very intricate way calculate all full area inside the staircase path. Divide by that. So now it looks like it is generic way, and this is called circulation density. Or someone can say that the net energy density of the path dependent energy source, that is the energy that is consumed from the energy source moving one particle in a closed loop, and then whatever energy is consumed divided by the area of the closed loop. Okay, this is called circulation density. Now there are other factors also. How to calculate energy? Energy calculation is force vector dot d of position vector. That is energy calculation. Force vector dot d of position vector. That is energy calculation. Okay, if that is the case, force vector dot d of position vector. Consider three dimension. Three dimension. Force is three dimension. We are not talking about xy plane. We are talking about 3D. So force vector is not in form of x, is form of F1i, capital F vector. Force vector is in form of F1i plus F2j plus F3k, where F1, F2, F3 are function, are algebraic function. 3D. 3D, if it is 3D in the case, then what would be the energy computation? Force vector F1i plus F2j plus F3k dot d of position vector. Any position vector, if I consider this is 3D, this is 3D, this is 2D. If this is xz plane, then it is 2D. If this is yz plane, then this is 2D. This is x axis, this is y axis, and this is z axis. X axis, y axis, z axis. Okay, 3D plane. If it is 3D plane, then this is xz plane, this is yz plane. If I take like this or like this is in xyz altogether. There is a force field F1i plus F2j plus F3k, and this is origin. Okay, or consider this is centered at the origin. If I take any point here, that is x comma y comma z, from here if I connect through a vector, then it will be like the vector xi plus yj plus zk. The energy computation is force vector dot d of position vector f1i plus f2j plus f3k dot d of xi plus yj plus zk. Net it will become f1 dx plus f2 dy plus f3 dz. Integration over integration in a closed loop. This much I can say. Integration in a closed loop. That is the work done kind of scenario. Now this integral f1 dx plus f2 dy plus f3 dz. Now in this calculation, it is considered as the kind of, it is in 3D. Now x, what is independent here? X is independent. Consider x is independent, y is independent, and z is dependent. Then z we will represent in terms of x and y. Now if x and y are changing, if I keep changing this, the path is a closed loop path. Okay, if it is a closed loop path, force vector is constant, that is f1i plus f2j plus f3k. But the position vector will keep, if this is centered at the origin, if I keep changing like this, keeping the origin same, then position vector will keep changing because it will have different direction. Force vector is same, but it will have different orientation. If I say it is in completely in xz plane, then y component will be constant. Either y can be 0 when it is sitting on the x-axis completely, or y will be 2, y will be 3, y will be minus 2, minus 3. Then full position vector equation will change. So see, this way position vector is changing as we change the path. This way, the energy is different for different orientation. What we are trying to calculate? We are trying to calculate energy computation in a closed loop divided by the surface area it is making. But energy computation is different for different kind of orientation. Now, where the energy is maximum, that is the question mark. If I keep changing f vector dot d of position vector, if the position vector is keep on changing, there will be one situation will come when this energy computation will be maximum. When it is maximum, then that by area is constant. That is the circulation density. Circulation density, this is also called circulation density. This is what we are trying to find out. Energy computation in a closed loop divided by the surface area of the closed loop. But energy computation is different for different kind of orientation. In what orientation the energy computation is maximum? That orientation, the maximum energy that it contains in particular orientation divided by the area of the closed loop. That term is called circulation density. Circulation density of the force field. Circulation density of the energy source. Now it is not dependent upon the path, because if you take bigger path, then energy will be more, then area will be also more. If you take a staircase of case kind of thing, energy computation will be different, then area computation will also be different. Now in that sense, it looks like a pretty generic. Now we can differentiate among the path dependent energy source looking at the energy density or circulation density. Calculate in a closed loop the circulation energy, divide it by the closed loop area. That is, that technology is called circulation density. Okay. Now this technology of circulation density, what is the energy if I move an item in a closed loop along the peripheral? If it is moving, along a curve, if it is moving back to the same point, what is the energy? Mr. Green is saying that energy is nothing but integration over the circular region of the df2 by dx minus df1 by dy dx dy, where f2 and f1 are component of the force field. If capital F equal to f1i plus f2j, then the net energy that is consumed from the energy source when particle is moving from point A and coming back to point A, the net energy it is losing, or net energy work done, is nothing but whatever is the area. Okay, so if we are taking x, y as independent component and z as dependent component, then integration over the area, the integration over the this 2D area, which is enclosed by the curve, closed curve, and then df2 by dx minus df1 by dy dx dy, whatever comes, that is the energy in closed loop. This is what Mr. Green says theorem. Whatever circular density, circular density is energy computation in a closed loop where it is maximum divided by the area, that is circulation density. Can we go with the Green's theorem and calculate the circulation density? Then it comes as whatever is the curl factor is there, df2 by dx minus df1 by dy. It is also called torque factor or curl factor. Torque factor or curl factor, if you remember very well, then if I have a point A comma B, okay, A comma B comma C, and there I have another point that is x comma y comma z. Okay, if I draw a straight line, then it is very all right. Or I can go from A, B, C point to X, Y, Z in three perpendicular way. One way is just move in Z direction, then move in X direction, then move in Y direction. You will reach there. Make sense? If I have a point A comma B comma C, and there is another point called alpha comma beta comma gamma. alpha, comma, beta, comma, gamma. A particle is moving from A, comma, B, comma, C to alpha, comma, beta, comma, gamma. Beta, comma, gamma. What is energy involved? Energy involved is the force vector dot displacement vector in a core term. If that is the case, then this displacement from one point to another point can be achieved in three straight lines. Okay, this may be a curved line also, or a straight line, but three straight line in the sense in orthogonal terms. One straight line, these are the 2 points. One straight line is going in z direction. Other straight line from where it ends is going in x direction. Another straight line is going in y direction. Then it reaches this point. Okay, a, b, c to alpha, beta, z. If it is two dimensional, then a comma b to alpha comma beta. One vertical, one horizontal, it reaches there. If it is 1D, then only one straight line. Yes. Okay, if it is 3D, then Z, X and Y, or Y, Y here, from here to here, then X here, and then Z, whatever comes to mind. Now, if there is dF1 by, if there is dF3, F3 is the third component of the force. If there is dF3 by dx, dF3 by dx, okay, means consider this is Z. Then Z is changing if I go along x-axis. dF3 by dx, dF3 by dy. This is y. This is y-axis. Means this f is also changing when we go along y-axis. dF3 by dx is there. dF3 by dy is there. Similarly, this is f1. dF1 by dz, dF1 by dy. Similarly, this is f2. dF2 by dx and dF2 by dz. F2 is changing if I go in z direction. F2 is changing if I go in x direction. dF2 by dx. dF2 by dx. Okay, if that is the scenario, then what is the kind of torque factor? Torque factor means if there is df, if consider there is df3 by dx, if this is df3 by dx, and I have taken kind of this is df3 by dx. If that is the case, then this f3 is in this direction, but this is changing if I go in along x-axis. If there is a path like this, then it will create torque like this because it is changing. If there is no df3 by dx, everywhere f3 is same, then it will push like this. Otherwise, it will create torque like this. If there is a df3 by dy, if I move along y, if there is a path like this, it will make a torque like this. If there is a df1 by dy, this is f1 and this is dy. If there is a path like this, then it will create torque like this. So all three are creating torque factor. So as per the kind of Mr. Green's theorem, the net energy calculation from one point to another, in a closed loop. In a closed loop, the net energy calculation is whatever the closed loop area is. Whatever the closed loop area is. Here, it will go in three dimensions. X from where to where, Y from where to where, and Z from where to where. Okay, and then curl factor, and then dx, dy, dz. Okay, this is the net energy computation. Let's go with the two-dimensional one. Then, if I go in two dimensional, consider this is x-axis, this is y-axis. Then this is the closed curve. As per Green's theorem, whatever the region is, integration over the region, and then df2 by dx minus df1 by dy, dx dy. Here integrand is df2 by dx minus df1 by dy. That is as good as fxy. It will come as an algebra fxy. dx dy integration over xy plane and then limit on the xy plane. It is a pure computation of volume. In calculus, it is pure calculation of volume. Now, what is circulation density here? If it is like this, then it is dx dy. If I divide it by dx dy, then everything goes and it remains there is the curl factor. We talked about curl factor, right? If I have 2D, one point is A comma B and other point is alpha comma beta, then reaching from this point to this point, I can have one line like this and one line like this. If there is df2 by dx, then df2 by dx, it will create a torque. If there is df1 by dy, it will create a torque. What is the net torque? df2 by dx minus df1 by dy. If there is a torque, then it is path dependent. Otherwise, it is path independent. If there is a torque, then whatever the curl factor is, df2 by dx minus df1 by dy, dx dy integration over the circular region is the net energy, divided by the area is the circulation density. Divide it by area, dx dy. Dx dy gone, and net it remains as df2 by dx minus df1 by dy. It is not that straightforward. The way I said that net energy calculation is df2 by dx minus df1 by dy, dx dy and integration, and all of a sudden you divide by dx dy. It's not that straightforward. But loosely it is like this. Then circulation density in a closed loop is energy computation along the curve, closed curve, divided by the area of the region that is found by the closed curve. That is the circulation density. Maximum you have to take. That is same as equal to the curl factor. That is df2 by dx minus df1 by dy. Because this energy computation along the curve, closed curve, is same as df2 by dx minus df1 by dy. The differential through which we have to integrate is dx dy over the closed region. Okay, circulation density is energy computation by the area. Here also by area. Area is dx dy. Dx dy goes away, and then the circulation density formula in terms of curl factor and Green's theorem is simply df2 by dx minus df1 by dy. If someone is very kind of uh, avid listener, he can now see that kind of who is focusing more, that the nature of the energy source, if nature of the energy source is circulation density, then that is equal to the curl factor or torque factor, and torque factor is df2 by dx minus df1 by dy. It is only dependent upon the force field, not on the path at all. Okay, so nature of the any path dependent energy source is nothing but how much is second component, jth component, that is f2. How much is f2 is changing with dx, df2 by dx, and then how much the first component, f1, how much is f1 is changing with the dy, df1 by dy. If I subtract, what is the net torque it would generate? That is the nature of the energy, path dependent energy source. What about if it is path independent? Then it is 0. df2 by dx minus df1 by dy is 0. If it is not 0, then how much it is? More it is, then it is more path dependent. And that is same as energy calculated in a closed loop divided by the area. Same. Okay, anyway, we will prove this Green's theorem. Okay, through Green's theorem, we can have circulation density. Later we will have some example. Then we will also see kind of path free kind of scenario in the circulation density or curl factor. Okay, curl free path, something like that. Path which is curl free or some many things we will see in the energy. This is the most important part in the kind of calculus algebra, because we are into energy now. How we can protect energy, how we can know the nature of the energy source. If I know that Earth gravitational pull is path independent, then lavishly I can rotate one rocket around the Earth in a circular fashion, knowing that no energy Earth is going to impart on it. One thing. Second thing is that other thing that is falling on the earth and those kind of things, that energy calculation quickly we can calculate, because it is not path dependent, path independent. Just look at the 2 point, begin point and end point. You can calculate the scenario. There are many things. Then we will do through it. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.